Now, we are going to take up problems on projections of lines. A line, capital AB, 80 mm long, has its end capital A, 20 mm above HP, and 30 mm in front of VP. It is inclined at 30 degrees to HP and 45 degrees to VP. Draw the projections of the line and find its apparent length and apparent inclinations. So this is the problem which is given, wherein it says a line capital AB 80 mm long. So since it is the line capital AB, as the notation from the introduction of lines, we know that capital AB is always the true length. If I represent the capital AB, that means it is in true length. So if it is the true length, then the line has to be parallel to any one of these planes. A line along has its end capital A is 20 mm above HP and 30 mm in front of VP. So one end of the line has been fixed and it is inclined at 30 degrees to HP. So which is the line? A line is inclined at 30 degrees to HP. So that means 80 mm long line is inclined at 30 degrees to HP and 80 mm long line is inclined at 45 degrees to VP. So this is because a true length is same both in the front view and as well as in the top view. So now we will going to analyze this problem by considering the three-dimensional drawing, how it will going to look like. So we're going to fix the point A. So he says end A is 20 mm above HP. So when you look from the front view, we can see that the line in the point A is 20 mm above HP. So since you are looking from the front view, the image will going to fall on the vertical plane. So that image is small a dash. So that is 20 mm above HP. And 30 mm in front of VP. So since it is, when you look from the top view, we can see that point capital A is 30 mm in front of VP. So when you look from the top view, that image will going to fall on the horizontal plane. So that we have represented by small a. It is inclined at 30 degrees to HP. So the line capital AB is inclined at 30 degrees to HP. So this is the line which is inclined at 30 degrees to HP. So as we know that it is the capital AB, so as obviously that line has to be parallel to VP. So when you look from the top view, we can see the distance. NDA is 30 mm in front of VP and NB is also 30 mm in front of VP, and that line is inclined at 30 degrees to HP. So the inclination of the line with respect to HP is seen in the vertical plane. So when you look from the front view, that image will going to fall on the vertical plane. We can see that small a dash, b1 dash, the length of the line is 80 and the inclination made by that is 30 degrees to HP. So this is the three-dimensional line wherein you are going to get the line, it is in space. And also it is inclined at 45 degrees to VP. So when you look from the top view, we can see the distance of 80 mm, that is capital AB2, which is inclined at 45 degrees to VP. The inclination with respect to VP is seen in HP. So we are getting the line. When you look from the top view, we can see that AB2 is the line which is inclined at 45 degrees to VP. So we have got this line and we have got this line, and when it is projected onto the respective planes, we will going to get it as a dash b1 dash in the front view and AB2 in the top view. The inclination made by this will be 45 degrees. Now the same thing we will going to take it in the orthographic projection now. So first we will going to draw the XY line and you mark XY and VP and HP. As we know that the NDA is 20 mm above HP and 30 mm in front of VP, if the distance is given with respect to HP, so always the distance is seen in the vertical plane. So from XY line you measure 20 mm and draw a horizontal line. And similarly, and 30 mm in front of VP, so 30 mm in front of VP can be seen in HP. So from XY line you measure the distance of 30 mm and you draw a horizontal line. And consider any point. From here you draw a vertical projector. So you're going to mark this point as a dash in the front view and A in the top view. It is inclined at 30 degrees to HP. So that means a 80 mm long line is inclined at 30 degrees to HP. So from A dash, by using the protractor, you measure an angle of 30 degrees with respect to the horizontal and to draw a horizontal inclined line at 30 degrees to HP. Similarly, by using the protractor with small a as center, measure an angle of 45 degrees because it is 45 degrees to VP. The inclination with respect to VP is seen in HP. So in HP, you measure an angle of 45 degrees with respect to the horizontal and then draw an inclined line. Then as we know that the true length of the line is 80 mm, so you measure by using the compass, you measure a distance of 80 mm with A dash as center, cut an arc on the 30 degree line in the front view, and similarly with A as center, you cut an arc on the 80 mm line on the 45 degree line. On 45 degree line you cut an arc so that you mark this point as B1 dash in the front view and B2 in the top view. Then join A dash, B1 dash and A, B2. So this is the true length in the vertical plane and this is the true length in the horizontal plane. So that is what we have done here. Now we need to find out what is the apparent length and apparent inclination. So that means we have to find out we have to find the front view and the top view. Now first we can consider any one of these planes. So what we will do, we will go to consider with AB1. So what I want is now AB1, I want to find out the top view. So to find out the top view with A as center, taking the radius of AB1, you rotate this line such that this AB1 is, this B1 is above HP by some distance, has to come to that it will going to come on this locus with A as center, taking the radius of AB1, you rotate it such that when you look from the top view, you will going to get the image which is AB2 here, AB1 here. So when you are rotating this such that it will going to come and cuts the locus of B in the top view. So you rotate till that B1 will going to come to the position of point B so that AB1 will going to come on the locus of B in the top view. So this is the line which is in space in 3 dimension. So as we rotate this capital AB1 with A as center, the image what you will going to here in the horizontal plane will going to be rotated till what? Till to the locus of B in the top view. So as it cuts the locus of B in the top view, you stop at this point and you mark this point as capital A and capital B. So this is the line which you are going to get it. So join. So when you look from the top view, that B will going to be on the locus of B which was here. So you will going to get this line small AB. So this will going to be the top view, and the inclination made by this top view with respect to VP is called beta. So now how to analyze that here? So we know this is the true length in the front view and this is the true length in the top view. We know that it is the true length because it is parallel to any one of this plane. Since it is in the front view, the line is parallel. In the front view, it is the true length. But we don't have the top view now. We need to write the top view for this particular line, that is A dash B1 dash. So to do that, I will write a top view for this A dash B1 dash. But we know the position of the point A. Now we want to find out the position of point B1. So how to find out that? So we have drawn already a horizontal line. So since this is the front view, this is the true length in the front view, obviously the top view line of this A dash B1 dash should be parallel to XY. So when you write the top view, so B1 you have to project from B1 dash till to the locus of A in the top view. So that means AB1 will going to become parallel to XY. If the top view line is parallel, correspondingly its front view will going to be in the true length. So you will going to get, since A dash B1 dash is the true length, so we are denoting that by capital A and capital B. So since it is the true length in the front view, obviously the top view line has to be parallel. By applying that condition, so A is here and it should be on the same line as the locus of A. So you are going to get this point B1. So we got this. Then, but we know in the top view, because due to the line is already inclined to VP at 45 degrees, so B2 is here, so we are going to get the locus of B here. So with A as center, by using the compass, with AB1 as the radius, you rotate this such that the locus of B, so that the B1 will going to come and cuts the locus of B in the top view. That's what we were explaining, that you are rotating that capital AB1 such that the B1 will going to come and cuts the locus of B in the top view, so that it will going to comes here. So when it is projected, it will going to cut the locus of B here. So that is what we have done here. So same thing with A as center, taking the radius of AB1, you are rotating this such that it will going to comes and cuts the locus of B here, and you mark this point as B and join AB with a dark line. So this will going to be the top view. Now in the similar fashion, we will going to write the front view. So how to do that? So to do that, you take the top view true length. You know this is the true length in the top view. That means it is parallel to XY line in the front view. So when you project this, A dash will be here. When you are projecting that B2 dash will going to come here. So we know that this is the parallel to HP. That means A is above HP by 20 mm and B2 should also be above HP by 20 mm. So that means A dash is above HP by 20 mm and B2 dash should also be above HP by 20 mm. Then only the line is parallel. Now the front view line is parallel. Therefore, its corresponding top view line is in true length. Applying that condition. Now what we are doing is with A as center, taking the radius of B2, you are rotating this B2 such that it will going to cut the locus of B in the front view. So you are rotating that B2 dash such that it will going to cut the locus of B in the front view, and you mark this point as B dash and join A dash B dash with a dark line. So when you are projecting this, you are going to get this point capital B here. So this will be AB. So similarly, we want to do it here now. So we have got the top view point and we also got the true length in the top view. So we need to make this line. So since it is the true length in the top view, obviously its front view line is parallel. So we have to write the front view for the top view line AB2. What is the front view for the top view line AB2? It should be A dash B2 dash. But we have A dash, but we don't have B2 dash. Now we need to get that B2 dash such that A dash B2 dash should be parallel to XY. So you project this from B2, you draw a vertical projector to the front view such that it will going to cut the locus of A in the front view so that it will going to get B2 dash. Now the line A dash B2 dash is parallel to XY in the front view. Obviously its corresponding top view is in true length, which has been denoted by capital A and capital B. But actually the locus of B in the front view is here. So with A dash as center, taking the radius of A dash B2 dash, by using the compass, you rotate it such that it will going to cut the locus of B in the front view. So you mark this point as B dash and then join A dash B dash with a dark line. So you will going to get the front view here. But when you want to check whether the problem is right or wrong, then join B and B dash, both will going to lie on the same line. Now we need to find out its apparent length and apparent inclination by using the scale. You measure the distance of A dash B dash and you measure the distance of AB. So AB will be equal to 69 mm when you are doing it in manual, and when you are doing it in computer you must get 69.28, and measure A dash B dash by using the scale. You will going to get, when you are doing it in manual, you will going to get 57, and when you are doing it in computer you will going to get 56.57. Then by using the protractor with A dash as center, you measure an angle of alpha with respect to the horizontal line. That alpha will be equal to 45 degrees and it is 45.00. So we are going to get it as 45 degree when you are doing it in manual. And similarly by using the protractor, you measure the angle of beta with respect to horizontal. So it will be 55 degree when you are doing it in manual. When you are doing it in computer, it will be 54.74 degree. So this is how we can analyze this problem in 3D, and also we can be able to do it in manual drawing. So in the next position, what we have shown, how individually we can do. This is just the explanation what we have given there, and we have split that, and by considering individually by step. So we have considered initially the position of the front view true length we have considered, and we have rotated such that it will going to cut the locus of B in the top view. So that is what we have shown here. To have a better clarity, we have shown that we have taken the front view true length first. Since it is the true length in the front view, obviously that line is parallel. So we have make it parallel here, and it with A center, taking the radius of AB1, we have rotated so that it will going to cut the locus of B in the top view so that you will going to get the top view point AB. So that is what we have shown here. And then you measure AB and also the apparent inclination with respect to VP. Similarly, in the same way, we are doing it in the front view also. So here you are rotating the front view. So that means you have taken the top view true length and you are rotated such that you will going to get the locus of B in the front view. So you are going to get this front view line. Similarly, here also you know the top view and this is the true length. So obviously that line should be parallel. So we made it parallel in the front view, and but in the front view that B2 dash should lie on the locus of B in the front view. So with A dash as center, taking the radius of A dash B2 dash, we have rotated such that it will going to cut the locus of B in the front view. So you're going to get A dash B dash, and you are going to measure the angle alpha and also the magnitude A dash B dash. That is what we have shown in 3D also. So this is how you will be able to analyze this problem in both 3D and as well as in 2D, and also by using stepwise. So how to do this problem in AutoCAD software, that I am going to explain in our next video. Thank you.